Hi grade 11s and welcome to the grade 11 exam review paper for term 1. In this video we will be covering topics in polynomial identities and binomial expansion, polynomial division, synthetic and long division, zeros of polynomial functions, roots of polynomials where we apply the conjugate, surds and complex theorems. Now we have about 26 questions to solve involving these 4 topics, and the first question we have is here: the coefficient of x cubed y to the power 4 in the expansion of x plus y to the power 7. So how do we go about solving x plus y to the power 7? But we want a coefficient. Coefficient basically means a number next to x cubed and y to the power 4. So in order to solve this problem, we use the Pascal's triangle, where we expand with a 1, starting with a 1, and it expands outwards. And now 1 plus 1 is 2. Expand the 1s. 1 plus 2 is 3. 1 plus 2 is 3. Expand the 1s in the side. 3 plus 1 is 4. Expanding the 1 again. 3 plus 3. Expanding the Pascal's triangle. 3 plus 3 is 6. 3 plus 1 is 4. Expanding. And now 4 plus 1 is 5. That is 10. That's 10. That's 5. Another 1 there. Expanding 1. Remember, this is x plus y to the power 0 to the power 1, 2, 3, 4, 5. We need 7 rows, about 8 rows. 1 plus 5 is 6. That's 15. That's 20. 10 plus 5 is 15. That is 6, and that's 1. Expanding one more row should solve the problem. 1 plus 6 is 7. That's 21. That's 35. We're just adding, and so on. 15 plus 6 is 21. 7, and then we have a 1. So we have this Pascal's triangle. Now I just make this thing a bit smaller. Right, since we have this Pascal's triangle here, which is solved to 8 rows, the last row should give us x plus y to the power 7. And guys, if you want to the power 8 to the power 9, and you just need to keep on expanding. Just trying to make this triangle smaller. Let's take all of this out. Now we have the Pascal's triangle. Now how do we use the Pascal's triangle? Remember, the first row is a plus b to the power 0. So this is 1, 2, 3, 4, 5, 6, 7. So we're looking at the 7th row. So we want x plus y to the power 7. So how do we solve x plus y to the power 7? We will start with the 1. So x plus y to the power 7 is equal to 1. We will make brackets like this. If you really want to expand everything, that's what you will do. Plus, put the next number 7 with the brackets, plus the next number is 21, bracket, plus 35, have a bracket and a bracket, plus another 35, plus 21, plus 7, plus a 1 with a bracket and a bracket. So what goes in the first bracket is the x and the y. So x, y, x, y, x, y, and you fill all this in. Remember, the first part goes as x and this a and b, so in this case is x and y. And now when we expanding the Pascal's triangle, we start counting from the highest power 7 down. So 7, 6, 5, 4, 3, 2, 1, 0. And for the powers of y, we count upwards from 0 up to 7. 0, 1, 2, 3, 4, 5, 6, 7. Remember, we wanted the coefficient of x cubed y4. So x cubed y4 is here. So what's the number next to x cubed y to the power 4? So the coefficient is 35. So coefficient is equal to 35. Whereas this x plus y to the power 7 has 8 terms. If you look at it, there are 7 different 7 coefficients. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 coefficients. So basically you should have 8 terms in this expansion. Remember, if you really want to expand x plus y to the power 7, you got to simplify all this. You know that y to the power 0 is 1, x to the power 0 is 1. So all of this can be simplified. We do have more questions where we have to expand to the power 6 or to the power 5. So we will revisit this Pascal's triangle. Looking at the second question. Question number 2 says, how many terms are there in the expansion of a plus b to the power 20? So guys, when you expand x plus y to the power 7, you can see there are 8 terms. 1, 2, 3, 4, 5. So there's always one extra term. So how many terms are there in the expansion of a plus b to the power 20? 21 terms. So pretty easy question on binomial expansion. There are 21 terms in this. Third question, expand 3x minus 5y to the power 6. So 3x minus 5y to the power 6, which is the third question. Let us expand this. Now we will apply our binomial expansion. We have already drawn our we have already drawn our Pascal's triangle above. So we will use the Pascal's triangle to expand this. Obviously there are easier formulas, but we need to apply Pascal's triangle for these cases. So looking at the Pascal's triangle, what we have is we want to expand x plus y to the power 6. So x plus y to the power 6, remember this was to the power 7, so x plus y to the power 6, we are looking at the 7th row. What I mean by 7th row is first, second, third, fourth, fifth, sixth, 7th row. Yes. So it's 1, 6, 15, 20, 15, 6, 1. So that's what we will write. We'll take 3x as our a and minus 5y as the b value. So how do we expand? We write 1 bracket bracket plus 6 bracket bracket plus 15 bracket bracket plus 20 bracket bracket plus 15 bracket bracket plus 6 bracket bracket plus 1 bracket bracket. Now what goes in the first bracket? 3x. So let's fill in all the 3x's. The 3x, the 3x, the 3x, 3x. Right. And what goes in the second bracket? The minus 5y. So minus 5y, minus 5y, and so on. Now for the powers of a, in this case this was your a and this was your b value. So we kind of like expanding a plus b to the power 6. So the powers of a, you start counting from 6 down. So what we will have here is 6, 5, 4, 3, 2, 1, 0. And for the powers of b, which is minus 5y, we count from 0 upwards: 0, 1, 2, 3, 4, 5, 6. So what we see now is we need to expand this in terms of coefficients and variables. So 3 to the power 6, remember minus 5y to the power 0 is just 1. Anything a term to the power 0 is 1 in this binomial expansion. So 3 to the power 6, we'll just use a calculator. 3 to the power 6, so 3 to the power 6 to the power 6, power button is here. 3 to the power 6 is equal to 3 to the power 6 is equal to 729. So 729 x to the power 6. Then the next one is we have to work out all the numbers first and then work with the variables. Remember, this is x to the power 5, y to the power 1. So what are the coefficients? 6 times, that will give me 6 times 3 to the power 5 times negative 5. So that will give me minus 7290. So that's minus 7290 x to the power 5 and y to the power 1. Y to the power 1 is y. Next one we have is 15. 15 times 3 to the power 4 times negative 5. So that will give me negative 60, negative 5 squared. There's a square there. So that will give me to the power 2. Yes, that should give me 30,375. 375. And this was x to the power 4, x to the power 4, y squared, plus will it be plus or minus? Should be minus, because what we have here is 20 times 3 to the power 3 times negative 5 to the power 3. So we have negative 67,500 x cubed y cubed. As you can see, the powers of x's are decreasing and the powers of y's are increasing. Next term, so is 15 in the front. 15 times 3 to the power 2 3 to the power 2 negative 5 to the power 4. That should give us a positive answer. Plus 84,375 x squared. X squared is x squared, y to the power of 4. Now we're just left with the last two terms. 6 times 3 is 18. So 6 times 3 to the power 1 times negative 5 to the power 5. Guys, just make sure that when you are raising powers, make sure to put the negative 5 in brackets to the power 5. So we're getting negative 56250, negative 56250 x y to the power 5. And the last term is pretty easy, because we got 3 to the power 3x to the power 0, which is 1. 1 times 1 is 1. But now we got to work out negative 5 to the power 6. So that's the only thing that we got to work out, which is negative 5 to the power 6. negative 5 to the power 6, 15,625. So plus 15,625 y to the power 6. And that's the expansion of 3x minus 5y to the power 6. So when you guys are studying, just double check your answer. How do you check this answer? You can use the online mathematical softwares, which is Wolfram Alpha. So 3x minus 5y to the power 6. So just want to expand that. 3x minus 5y to the power 6. Just want to check my answer. The expansion of 3x minus 5y to the power 6 is the expanded form. It's right here, and let's check if we got the same answer. So you should get 729x to the power 6 minus 7290. Yes, we do have the same answers. 84,000. Yes, perfect. So this is basically using the online software. You can use it for studying purposes. Let's look at question number 4. In question 4, the constant term in the expansion of yes, so some questions are easy, some questions are you've got to work out, like something like this. You've got to work out every single term using the Pascal's triangle. The constant term in the expansion of, since we want the constant term in the expansion of all of this, the constant term is usually dealing with a constant. So the easiest way to do is look for the constant in the binomial expansion, which is negative 7, and raise it to the power 8, because it's to the power 8 that we want. So that's how easy this question is. So negative 7 to the power 8, we need to work that out. Negative 7 to the power 8, 5,764,801. 5,764,801. That should be the constant term. 5,764,801. And by the way, there's no need to expand everything to 9 terms here. So that's my answer. Let's just double check with our online calculator and see where's the constant term if you really have to expand this to all the terms in the binomial expansion. 8x minus 7 to the power 8. So let's check. 8x minus 7 to the power 8. 8x minus 7. 8x minus 7 to the power 8. So check what answer we get. Yes, so we are looking for constant term. Constant basically means term that contains no variable, just numbers only. So the term that contains the term that contains no variables, or is just a constant, is the last value, and you can see that's what it is. And how do we get the last value? Minus 7 to the power 8. So you don't need to go and work out everything, we just need that particular value. That's what a constant means, no variables. Constant term means no variables in this case. Next problem. Yes, we want to factor some polynomials. Question number 5. Yes, so how do we factorize or factor 81 x to the power 4 minus 625? So how we can factor this out is we can think about this as being a square and that as being the square. So a squared minus b squared, we know, is a plus b into a minus b. So how do we get this a? We have to square root the a squared. So if you square root this, you will get 9x squared plus, and if you square root 625, you get 25. So 9x squared plus 25 and 9x squared minus 25. Now because the question was factorizing completely, you've got to factor everything out. So obviously 9x squared plus 25 you can't really factor into real zeros, so that one remains the same. But 9x squared minus 25, you can factor this out as difference of two squares as well. So that's 3x plus 5 into 3x minus 5. Next question. We want to factorize 8x cubed minus 125. Factorizing 8x cubed minus 125 is, what's the rule? The rule is if we have a cubed minus b cubed, we say this is a minus b. Now towards the cube root of a is a, cube root of b cubed is b, and watch for the second bracket, we have a trinomial here, so we'll square the first term a squared, we square the last term b squared, and the middle term will be the product of ab with the opposite sign, so minus ab. Remember the last term was squared, so it's positive, so it's always the middle term. So if I start off with a plus, then I will have a if I started with a minus, I should have a minus here, minus, and that should be a plus. So doing it again, the middle term is only important thing that you got to get. Remember, is binomial, then a trinomial. So a minus b, then a squared, and we have the b squared sorted. So the product of a times negative b is negative ab with the opposite sign. So the sign must be opposite, so plus ab. Now if we start with a plus, then obviously this needs to be a plus, and then the product of these two with that, so that will be a minus. So follow the red with the red and the blue with the blue. Now 8x cubed minus 125, so your a in this case is the cube root, so your a in this case is the cube root of 8x cubed, which is 2x. Cube root of 8 is 2, cube root of x cubed is x, and the b in this case is negative 125. So in other words, your b in this case is 5. The cube root of 125 is 5. You can find the cube root on the calculator. Shift with the cube root here of 125, you can see we get 5. So if we factor this out, we will get 2x minus 5. Now if we square the 2x, we will get 4x squared, and if we square the minus 5, we will get plus 25. Now remember, we still have to go and solve the middle term. We still have to work out the middle term. The middle term is the product of AB, in other words 2x times minus 5, which is minus 10x with the opposite sign, so it becomes plus 10x, and automatically the second term you cannot factorize this further, and you got to stop here. Next question. Right, so the question says use the remainder theorem to find the remainder when this polynomial x to the power 4 plus 9x minus 11 is divided by x minus 12. So there's many ways to do this problem. The easiest way is to set up the polynomial function. You can just say p of x, and which is equal to x to the power 4 plus 9x minus 11, and we can just substitute the 0, because they said when it is divided by x minus 12, we can just substitute 12 inside the 0 of this divisor, which is 12, because we want the remainder only. Okay, so we just want the remainder, so we just substitute 12 inside this function and get the answer. So the what we can say is 12 to the power 4 plus 9 into 12 minus 11, and we have an answer of 20,833. 20,833. 20,833, which is the remainder, and that's the remainder. Now, is there another way to do it? Yes, you can use synthetic division to solve this problem. So using synthetic division, uh, we can put the 12 on the outside. So we have the 12 on the outside, and we got, write this polynomial in order. We got 1, coefficient of x cubed. Coefficient of x cubed is 0. Coefficient of x squared, there is no x squared terms, there is no x cubed term, so 0, 0. Put it in polynomial order. Then we got 9, and then we have minus 11. So x to the power 4 polynomial function must have 1, 2, 3, 4, 5 terms in general. So that's the reason why we have 0 there, 0 there. That represents. Now, how do we do synthetic division? We bring the 1 down. The advantage of doing synthetic division is that you get the quotient and the remainder as well. In this case, because they asked us for the remainder, we can just substitute this 12 inside here, inside the polynomial function, and get the answer. In this case, bring down the 1, then we have multiply and divide. So what we do is now we take this and multiply them out. 12 times 1 is 12, put the answer here, and then add them up, 12. 12 times 12 is 144, right? See, you have to multiply and add, so 0 plus, first we multiplied 12 times 1, we got that answer, 12. Now we added 0 plus 12, we got 12. Now you start the process again, 12 times 12, so you get 144. Now we add 144. Now because these are large numbers, you are allowed to use your calculator. We'll take 144 times 12, and we will get 1728. 1728. And if we add up 9 plus 1728, should get 1737. Now remember, 1737, we have to take this and multiply it by 12. So I need to add 9 here. So I've got 1737, then times 12 again. If I multiply it by 12, I get 20,844. 20,844. And if I add them up, add 20,844 to minus, and add it to minus 11, you get 20,833. And this is my remainder. And remember, this part represents your quotient, which the question did not ask for. If they did ask for a quotient, the quotient will be, there are 4 terms, so it's a cubic function. So x cubed plus 12x squared plus 144x plus 1737 will be your quotient, which is q of x. They did not ask for the quotient, they just asked for the remainder. So this will be the easiest method to solve by just substitution. Looking at question number 8. Very nice question on factor and remainder theorem. Is 2x plus 3 a factor of the polynomial? So how do we know whether if something is a factor? So if we substitute the 0 of this factor inside the polynomial, and if we get a 0, if remember the rule that says if p of a is equal to 0, if you substitute a value like x is equal to a inside the polynomial function, and if you get a 0, then only this part is a factor. So in this case, our a value will be the 0 of this factor, which is x is equal to negative 3 over 2, and my polynomial function is this. So I will say polynomial evaluated at minus 3 over 2, which is equal to 2 into minus 3 over 2 cubed, minus 3 into minus 3 over 2 squared, minus 3 into minus 3 over 2 minus 3. All we did was we substituted negative 3 over 2 in the place of that x, which is the polynomial function. And now let's check if we get an answer of 0. So let's see. So we got 2 into negative 2/3 to the power 3 minus 3 into negative 2/3 to the power 2 minus 3 into negative sorry, it's not negative 2/3, it's negative 3 over 2. So let's do it again. 2 into negative 3 over 2 to the power 3 minus 3 into, you can substitute 1.5 if you find that faster, minus 3 over 2 close bracket, make sure you close the bracket properly, squared. Yes, we're on the right track. Minus 3 into negative 3 over 2 and then subtract a 3 and we get an answer of negative 12. So what can we say? Is 2x plus 3 a factor of the polynomial? Because it's not equal to 0, we can say 2x plus 3 is not a factor, because the remainder is not 0. Only if the remainder is 0, then it will become a factor. So it's when we substitute negative 3 over 2, we get remainder of negative 12. Now let's verify this using synthetic division. Remember, whenever we have a single factor, we can always apply the synthetic division rule. So what we're going to put on the outside is negative 3 over 2. And let's put this polynomial in order. We got 2, negative 3, negative 3, and negative 3. Perfect. Let's bring the 2 down. And now 2 times minus 3 over 2, if you apply this with a calculator, you should get minus 3. Add up both, you get negative 6. Right, remember you're multiplying and then you're getting that number. Multiply and then you're adding vertically, add. So minus 3 over 2 times 2 is negative 3. Add both, you get negative 6. Minus 3 over 2 times negative 6. Let's work this one out on the calculator. Minus 3 over minus 3 over 2 times negative 6. Right? We get 9. Add both, you get 6. Minus 3 over 2 times 6 now. Times 6, you should get negative 9. Okay? Should get negative 9. Right, so we multiplied minus 3 over 2. Right, to get all these numbers is by multiplication of these bottom ones, so you get that one. Minus 3 over 2 times 6 is negative 9. Now if we add up both, we get minus 12. So that's my remainder. So remember, this is the remainder, this is your polynomial, that's kind of like your divisor, and this is your quotient. So your quotient is 2x squared minus 6x plus 6. Let's write it down. 2x squared minus 6x plus 6. So since we took the polynomial and divided by 2x plus 3, we got a remainder of negative 12. So this is, therefore, what can we conclude? Therefore 2x plus 3 is not a factor. So same, 2x plus 3 is not a factor. Therefore 2x plus 3 is not a factor. So two methods to do that problem. So that was question 8. Continuing, let's look at question number 9. Good question there. Question number 9. If polynomial p of 2 equals 0, then this means that, what does this mean? P of 2 equals 0. I just explained it in the previous question. P of 2 equals to 0 means we have a polynomial p of x, right, is divided by x minus 2, because we substituted 2. Then the remainder is 0. This basically means that x minus 2 is a factor of p of x. Or you can also say x is equal to 2 is a 0 Why is a 0? Because it gives remainder 0. Is a 0 of polynomial p of x. Okay, so this question is kind of like a theoretical question that defines like factor and remainder theorem. Looking at next question. Question number 10, guys. When x cubed minus 6x squared plus 19x plus 6 is divided by x squared plus 4x plus 3, the remainder is. So we want to see what's the quotient and the remainder. Remember, whenever a polynomial, for polynomial division, we say p of x when it's divided by d of x, we say the answer is quotient q of x plus r of x, which is remainder over the divisor d of x. Now in order to solve this problem, because we have x squared plus 4x plus 3 is a quadratic polynomial divisor, so this is your divisor, this is the polynomial, is a cubic function. We can't use synthetic division, so in this case we use the long division. So let us apply long division to this problem. Applying long division, remember the polynomial goes on the inside, which is called the dividend. Right, so let's apply long division here and just need some space. Now how do we do the long division? Is by using divide, multiply, subtract, bring down rule. Divide, multiply, subtract, bring down, or you can use dad, mom, sister, brother. So divide, multiply, subtract, and bring down. Now let's apply this. Remember, x squared plus 4x plus 3 goes on the outside, so x squared plus 4x plus 3 goes on the outside. The polynomial goes in on the inside in that order. So x cubed first, then x squared minus 6x squared. Just say if there was no x squared term, then you'll put plus 0x squared. Now since there is a x squared term, we put minus 6x squared plus 19x plus 6. Now that our division is set up, we can divide. Start with the first rule, divide. So if we take, what do we divide by? We take the leading term and we divide by the leading term here. So x cubed divided by x squared, so we have divided, which is x cubed divided by x squared is x. Now we multiply the x with all these three terms. So x times x squared is x cubed, x times 4x is plus 4x squared, x times 3 is 3x, and now we subtract, and you carry on repeating this process. So if we subtract, we get 0. Minus 6 minus 4 is minus 10x squared, and then we have 19x minus 3, so which is minus 16x. 19 minus 3, and now we bring down the 6 because we have multiplied, we have subtracted, now it's already time to bring down. Now we have brought down the positive 6. Again we start with the process again, we divide. So we take minus 10x squared divided by x squared, so we get minus 10. And now we take minus 10 and multiplied by x squared, so minus 10x squared. Minus 10 times 4, minus 40x. Minus 10 times 4x is minus 40x. Minus 10 times 3, which is negative 30. And now we add them up. So if we subtract, not add, we subtract them. So we have minus 10 minus minus 10, that's 0. 16 plus 40, that's 24x, because it's minus 16 minus minus 40, minus 16 plus 40, which is 24x. And then we got plus 6 plus 30, because 6 minus minus 30, so that's going to give us 36. So this is my remainder, and my quotient is x minus 10. So if I have to write it in this form, remember p is x cubed minus 6x squared plus 19x plus 6, and if we are going to divide it by x squared plus 4x plus 3, we're going to get this answer, x minus 10, which is the quotient, right? plus the remainder plus 24x plus 36 all over d of x, which is x squared plus 4x plus 3, and that's my answer. Let me block this out, the answer part. Let's put it in. So that's my answer here. Right, so let's just put it below this. So I've got a quotient and I've got a remainder. I'll just keep it there. Right, next question. So my quotient is x minus 10, my remainder is 24x plus 36 over x squared plus 4x plus 3. Next question. Again, we need to apply long division. For example, number 11. Applying long division here, because it's a x to the power 5 function with x to the power 3 function, we'll apply long division. We can't really use synthetic division here, right? Because we can't use synthetic division because we don't have a single factor. Divisor is basically a cubic function. So applying long division here, we want the quotient and the remainder. Let's see. Alright, so we have 16x to the power 5. We don't have any x to the power 4 terms, so 0x to the power 4 plus 0x cubed. We don't have any cubic terms, plus 0x squared. We don't have any x squared terms. Then do we have any x terms? Yes, we do. We have minus 8x and plus 25, and on the outside we got 2x cubed plus 0x squared plus 0x plus 9, because we don't have any x squared and x terms. Now the first thing that we do is we divide. So we have 16x to the power 5 divided by 2x cubed. So 16 divided by 2 is 8. X to the power 5 divided by x cubed is x squared. Now we multiply all this out. We divided, now we multiply. So we will get 16x to the power 5, 8x squared times 0, so it will be 0x to the power 4, 8x squared times 0 again, 0x cubed. And then we got 8x squared times 9 plus 72x squared. Now we subtract, divide, multiply. We divided, we multiplied, now it's time to subtract. So 0, that's also 0, that's also 0. 0 minus 72x squared is minus 72x squared, right? It's minus 72x squared. Then that's it. Now it's time to bring down. So we have minus 8x. Now remember, cubic term, 4 terms cannot go into 2 terms, so we put plus 0x, and now we do another bring down, plus 25. Polynomial order. Why did we put plus 0x? Because after x squared comes the x. Now when we bring down the 25, still 4 terms. Cubic function cannot divide 3 terms, 1, 2, 3, 4 terms. There are 4 terms here, cannot go into 3 terms, so you stop. So this is your remainder, right? And this is your quotient. Right, so what did they ask us for? The quotient and the remainder is, so what's the quotient? Quotient q of x is equal to 8x squared Now you stop because 4 terms cannot go into 3 terms. We stop. Yes, q of x is equal to 8x squared, and what's the remainder? R of x is equal to negative 72x squared minus 8x plus 25. And if you want to write it in the other form, where we have p over d equals q plus r over d, if you want to write it in this form, we have this polynomial here, which is 16x to the power 5 divided by 25. Let's copy that and put it here. If you want to write it in that form, this is what we get, which is equal to 8x squared plus negative 72x squared minus 8x plus 25, the remainder, all over the divisor, if you want to write it in this form. What's the divisor? 2x cubed plus 9. Yeah, so that's long division. There is no other method. This is the only method using long division. You can use detached coefficients where, but let's just keep it to basic long division. This is how we do it with polynomials. That's it. There are other methods as well, which is beyond our scope. Next question, question number 12. Solving question number 12, let's see what we get. The zeros of the function. Now, very important, zeros of this function. What are the zeros of this function? What values of x must I substitute into this function so I get a 0? So I can say x minus 2 is 0. So zeros are x is equal to 2, x is equal to negative 1, and x is equal to 0 twice. In other words, 2 times is equal to 2 times. Now, it's very important that whenever a 0 is repeated even number of times, there's always a turning point at that function. So we're trying to describe the behavior of the zeros of the polynomial function. So because the number 2 is even, there will be a turning point. So assuming we have an additional question, something like this, where we have f of x, which is equal to, where did we get this last 0 from? Because of this x squared. There's 3 factors here. So f of x is equal to, what if we said x minus 2 to the power 4, x plus 1 to the power 6, not 6, 5, and we got x squared here. Then what we can say is zeros are x is equal to 0, but that's 2 times x is equal to 2, that's multiplicity 2 multiplicity 4, so this is repeated 4 times. And so now whenever it's even number of times, there's always a turning point. So the turning point is at TP, the turning point will be at 0, 0 on the x-axis. In other words, over here the turning point will be on the x-axis as well. So turning point here, or the vertex, turning point or the vertex will be at 2, 0 on the x-axis, and the last 0 was x equals negative 1, but that is 5 times. Because it's an odd number of time, because it's odd, it will just be an x-intercept. This is just an x-intercept. X-intercept. It will just cut through the x-axis. Intercept. Right. So it just basically cuts the x-axis. You can't say there is a turning point or a vertex at x is equal to negative 1. So x-intercept is negative 1. So what are the zeros? Zeros are 0, 2, and negative 1. But because of multiplicity, you can see this is like x to the power 11 function. So you kind of do have 11 different roots. we'll talk more about roots in the upcoming question. Solving this inequality, question 13. Right, so solving this inequality, it is already factored out. Since this inequality is already factored out, what we can do is we can put the zeros of these factors on the number line. So zeros are x is equal to 0 or 1 or negative 3. So if we put this in order, we get negative 3, 0, and then a 1. If we substitute any value less than negative 3, any value less than negative 3, like negative 10, we will have 1 negative, 2 negative, 3 negatives. So we're substituting any value less than negative 3 and we're substituting it inside here. So if I choose negative 10, the first is negative, the second is also negative, and the third bracket is also negative. So we have 3 negatives, which is negative. Since we get one of the signs, the rest of them will just be alternating. Why it alternates is because these are all linear factors, linear, and there's no powers. So it is just alternating. And the answer that we are looking for is a positive answer. So the positives are between -3 and 0 and greater than 1. So this is the number line solution. Writing it in inequality, x is greater than -3 but less than 0, or x is greater than 1. And writing it in interval notation, x is an element from -3 to 0, O means union, 1 to infinity. That's interval notation. Looking at the next question, so you must know how to draw a number line solution, an inequality solution, or an interval solution. You must know all three, how to write them out. Next one, question number 14. Let's solve question number 14. Find the real or complex solutions of. Now, in order to solve this, remember this here is difference of two cubes identities. So we need to apply the polynomial rule, which is a cubed minus b cubed is equal to a minus b into a squared plus ab, middle term, product of the first two with the opposite sign, plus b squared. So to factorize this, we will have x minus 3, because your a is x and your b is 3, because square root of 27, cube root of 27 is 3, and the cube root of x cubed is x. Anyway, squaring this, we get x squared. Square the 3, we get plus 9. And the product of these two, the opposite sign, will get plus 3x. Now, to solve the first bracket is easy. We get x is equal to 3, or remember, x to the power 3 means 3 roots. So not necessarily the real roots. You can get real and complex root, and due to multiplicity we will get 3 roots. The next one is x squared plus 3x plus 9 is equal to 0. Remember, the value of a is 1, b is 3, because it's a quadratic function, quadratic equation now, and c is 9. So to solve this equation, we use the quadratic formula, negative b plus minus the square root of b squared minus 4ac. I will show you on the calculator how to solve this cubic equation and get all these three answers with the complex and real roots. Right, divided by 2a. So minus b will be minus 3 plus minus b squared. If I square b, get 9. 4ac, 4a will be 4, and times c, minus 36. 4ac will be minus 36, and divided by 2a. 2a just divided by 2. So now I have minus 3 over 2 because I split them up, plus minus. If I find the square root of negative 27, because 9 minus 36, square root of negative 27 Yes, in this case you can't find that. So remember, square root of negative 27, you can just say square root of negative 1 is I, and the square root of 27 instead. Just find that square root of 27 is 3 root 3. So you get 3 root 3i. So 3 root 3 over 2i. So those are my three solutions. Remember, there's two solutions here, two complex solutions and one real solution. Right, so this is the real part and this is the complex part. That's the complex solutions. Why is a complex solution? Because we have the complex number I in the square root of negative 27. Now to solve it on the calculator, we were solving the equation x cubed. You go to mode, equation, and you go to the cubic equation, ax cubed plus bx squared plus cx plus d is equal to 0, 4. Remember, it was x cubed minus 27. So we only had the first term and the last term, so b and c are zeros. So we got 1, coefficient of the number next to x cubed is 1, 0, 0, because 0x squared plus 0x minus 27. And if we press equals, we should get x is equal to 3, and the other solution, there's it here, minus 3 over 2 plus 3 root 3 over 2i and minus 3 root 3 over 2i. Right, so you can go and split the solution up, which is x is equal to minus 3 over 2 plus 3 root 3 over 2i, or x is equal to minus 3 over 2 minus 3 root 3 over 2i, and those are the three solutions, and x is equal to 3, which is the real part, and those are the complex part. Now next question. This was question number 14. Perfect. Question number 15. Question number 15, what we have here is find the real or imaginary solutions of. When you find the real or imaginary solutions of. So if you're looking at this quadratic, we can call it a quadratic because if we bring everything over, we got 4 x to the power 4 minus 25 x squared plus 36 is equal to 0. Now we can think of this as a quadratic function because it's only 3 terms, right? And we can say let x squared be equal to k. So you can kind of do this 4 x squared squared, 4 say 4 x squared. You can break up the x squared into x squared times x squared, so 2 plus 2 is 4 minus 25 x squared plus 36 is equal to 0. So I can say I can replace the x squared with k. Let x squared be equal to k. So I have 4k times k, which is k squared, minus 25k plus 36 is equal to 0. And now I can use a quadratic function to solve for this. So I've got, I think you will get 2k plus, should get 2k minus 9. Let's see, should get two different answers. Right, so we'll just use a calculator to factorize this. 4 minus 25 and 36. Go to mode, equation, and quadratic function, which is number 3. So we want 4 minus 25 and 36. So we're getting these answers. X1 is equal to 4, so obviously k minus 4 into 4k, last one should be 4k minus 9. Because we're getting x is equal to 4, we bring the 4 over, you get x minus 4. Don't put x now because you're solving for k. And the second solution says we're getting 9 over 4. That's what it says. Now if you take 4 times, if you cross multiply, 4 times x2 is 4x2 and bring it over, you get 4x minus 9. So there's it here. But now remember, what is k? What is k? K is basically x squared minus 4, right? And we got 4k, which is 4x squared minus 9. Now remember, x to the power 4 function basically says, x to the power 4 function means we need 4 roots, real or imaginary, right? So we need 4 roots of this equation. So we are getting 4 roots because now this here itself you can factorize into x plus 2 into x minus 2 because it's difference of 2 squares, and this one here is also a difference of 2 squares, which is 2x plus 3 into 2x minus 3, which is equal to 0. So all my factors are real. So therefore x is equal to minus 2, x is equal to 2, or x is equal to minus 3 over 2, or x is equal to 3 over 2, or you can write it as a set, plus minus 2 and plus minus 3 over 2. So there's 4 answers here as well, because plus minus means 2 answers, right? So there's 4 answers here, or you can write it in a set notation. Is there another way to solve this problem? Yes, there is another way to solve this problem, which is 4x to the power 4 minus 25x squared plus 36 is equal to 0. So we're saying 4x to the power 4 minus 36x squared minus 25x squared plus 36 is equal to 0. Yes. Now if I look at 36, all the factors of 36, there's many factors, so we need to look at the factors, which is factor and remainder roots of polynomial function. So factors of 36 divided by factors of 4. So we can look at some of the possibilities like plus minus 1, plus minus 2, right? Those are some of the possibilities. So we can say x is equal to 2 is a root. How we know x is equal to 2 is a root? Or we can say x is equal to 2 is a root. Possible factors, let's list all the possible factors. So I tried x is equal to 2, it works, and if I try x is equal to negative 2, that also works. Or so let's see, possible factors are plus minus 1. Obviously 1 does not work because you got 4 minus 25 plus 36, right? And minus 1 won't work as well because it's square square. So I have eliminated plus minus 1. Now I'm trying plus minus 2. So do the substitution. 4 into minus 2 to the power 4 minus 25 into minus 2 to the power 2 and plus 36. See, I'm getting a 0, and if I substitute 2 as well, I will get 0 because I already have 2 possible factors. It's not actually guessing because you're listing all the possible factors and then you're trying it in order. So now you bring in this over, you get x minus 2, and if you bring that over, it's a factor of this polynomial. Because these are zeros, I'm trying to get the factor out, which is x plus 2. Now if I multiply x minus 2 with x plus 2, I will get x squared minus 4. Now I'm kind of taking this polynomial, I'm calling this the polynomial, which is 4x to the power 4. I'm calling this the polynomial, which is p of x, which is 4x to the power 4 minus 25x squared plus 36. Now I'm taking 4x to the power 4 minus 25x squared plus 36 and dividing it by x squared minus 4 because I've already found 2 zeros. So I will apply long division here because it's x to the power 4 divided by x squared minus 4. Alright, so if I apply long division, I'll get 4x to the power 4 plus 0x cubed minus 25x squared plus 0x plus 36, because there's no x terms and there's no x cubed terms, and this is x squared plus 0x minus 4. And now we divide, multiply, subtract, bring down. Now 4x to the power 4 Remember, we need to end up with the remainder of 0 because these are zeros. So 4x to the power 4 divided by x squared is 4x squared. 4x squared times x squared is 4x4. 4x squared times 0 is 0x cubed. 4x squared times minus 4 is minus 16x squared. Divided by, we're going to divide it by, not divided, yes, so we divided, we multiplied, now we're subtracting. So if you subtract both, you get that, subtract both, you get 0. And if you subtract both these two terms, minus 25 plus 16 is minus 9x squared. Bring down the 0, x. Now you can see 3 terms cannot go into 2 terms, so you put plus 0x. And now you do a double bring down, that's the reason why we put a 0x plus 36. Now we take minus 9x squared. We take minus 9x squared and we divide it by x squared. So what do we get? We get minus 9. Minus 9 times x squared, minus 9x squared. Minus 9 times 0, 0x. Minus 9 times minus 4, minus 9 times minus 4 is plus 36. And as we expected, we get remainder 0 because we're subtracting. Now, what's my quotient? We are left with 4x squared minus 9. So 4x squared minus 9 is equal to 0. And we factorize this. So we get 2x plus 3 into 2x minus 3 is equal to 0. So x is equal to negative 3 over 2 or x is equal to 3 over 2. So we have all 4 possible roots. So we have all 4 possible solutions. Actually, we need 4 solutions, so we managed to get all 4. Next question, question number 16. Question number 16. We want to solve the inequality, which is 4x squared minus 25 into x squared minus 9 less than 0. Show the solution on the number line. Now this is something similar to what we have done above, but we're not solving for x, we are solving for inequality solution for x, because this is an inequality. So we have to factorize fully first. So 4x squared minus 25 can factorize as 2x plus 5 into 2x minus 5 because it's difference of two squares. Then x squared minus 9 can factorize as x plus 3 into x minus 3, which is less than 0. Right guys, factorizing this polynomial, we look at the difference of two squares here in the first bracket and difference of two squares in the second bracket. Now we draw a number line and we solve the inequality. We put all the zeros on the inequality. The zeros are minus 3 from this. There are 4 zeros, minus 3. The next 0 is minus 5 over 2. And these are all linear factors. So if you get one of the signs, the rest of them will just be alternating. So we got 2 zeros. The next one is 5 over 2. And the last one is 3. So these are the 4 zeros that we put on the number line, and we will work out the solutions. So if you take any value less than after 3, let's take after 3, like 100. We substitute 100 here, positive, 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 positive. We get all positives, so that one is done. Now the rest of them will just alternate, negative, positive, negative, positive. Now we are looking for negative solutions, so negative solutions are in between here and in between minus 3 and minus 5 over 2. So if we have to write out the solution, it will be negative 3. X is greater than negative 3 but less than minus 5 over 2, or between 5 over 2 and 3, that's an x less than 3. And writing it in interval notation, it will be from -3, remember round bracket because it's not including, to 5/2. O means union 5/2 to 3, and that's my solution. Make sure you know how to find the solution on the number line, then inequality, as well as interval notation. All three notations, all three are part of the solutions. Looking at the next question, number 17. What's question number 17? Right, so question number 17 is on functions and finding zeros or behavior of the function at each of its zeros. Let's look at this. We have done this problem before, but anyways, practice more question means more practice, right? So we can say x is equal to -1 is a 0, but is 4 times, so multiplicity 4, right? And we got x is equal to 2, but this is 3 times, which is multiplicity 3. So remember, the 4 here is basically the 4 here is even, so there will be a turning point or vertex at -1, and that's just an x-intercept. So you can see there are 7 solutions. -1 is repeated 4 times and 2 is repeated 3 times. So in total there are 7 solutions, but anyways, since this is even, there's a vertex at -1 and 0, and since this is odd, there's a x-intercept only, x-intercept at 2, 0. So the curve just goes through 2, 0. Continuing on to the next question, question number 18. Question number 18 says use the polynomial identities to multiply the number. Was question number 18? Use the polynomial identities to multiply the number 19 times 21. So it's a nice question. 19 times 21, we can use difference of two squares. So 19 is 20 minus 1, and 21 is 20 plus 1. And now you know that is 20 squared minus 1, which is 20 squared is 400 minus 1, which is 399. So this just some quick mental math that you can do. So what you can do is you can take the midpoint of the number, which is 20. So 20 minus 1, 20 plus 1, and then it's easy after that. Next question. We want to expand, use the polynomial identities to expand the expression. So how do we expand the expression? 20, question number 19. Right, now we are squaring a binomial, so we know the rule for squaring a binomial, which is a minus b all squared, which is a squared plus 2ab plus b squared. So in this case it will be minus here now because there's a minus there. So your a is kind of like 3a cubed here, right? And your b is like your y squared here. So 3a squared minus y squared squared is 3a cubed. That's going to be applying it into this formula here. You're going to have 3a cubed squared. Last term is y squared squared. Middle term is 3a cubed with a minus 2 and y squared here. Right? So expanding all this, 3 squared is 9, a cubed squared is 3 times 2, don't add, it's multiplying, raising a power to a power, we multiply, a to the power 6. Next one, minus 2 times 3 is minus 6, a cubed y squared, and y squared squared is plus y to the power 4, and that's your answer for the expansion of this using polynomial identities. Next question, number 20. List all the possible rational solutions for the equations. So what are possible rational solutions? So remember, the last value are like factors of p, and the first value, the leading coefficient, is the factors of 3. So p, I like to call it just p6. P6 is like all the possible factors of 6 is 1. 1 can divide 6, 2 can divide 6, 3 can divide 6, and 6 can divide 6. And for q, all the possible factors of 3. Remember, 1 can divide 3 and 3 can divide 3. So all the possible factors is in the form p over q. List all the possible factors. So is 1 plus minus 1, because 1 over 1. So you kind of like taking p over q, all the possibilities. Then the next one is plus minus 2 over 3. Then the next one is plus minus 3 over 1. We were doing, yeah, so plus minus 2 over 1, which is 2, because we are done with 1 1 and 1 3. Plus minus, 1 second, we didn't do the 1 3. That should be, this should not be 2 over 3, that should be 1 over 3. So again, we're taking this p over q and then into that. So 1 over 1 plus minus 1, 1 over 3 plus minus 1 over 3. Then we're moving on to the next value, plus minus 2, then plus minus 2 over 3, then plus minus 3, and then plus minus 3 over 3, which is plus minus 1 is already there, do not repeat. Then the last one is plus minus 6, and the last one is second last this was, and the last one is plus minus 6 over 3, which is plus minus 2, is already there. So these are all the possible factors. These are all the possible zeros that can, these are all the possible rational solutions for this equation. We don't really need to solve this equation, we just need to list all the possible rational solutions. We're not saying these are the solutions, we're saying these are the possible rational solutions. So these are p over q is possible solutions, possible roots, possible solutions, or another word for solutions to equations is possible roots of the rational function. Next question. Question number 21. Use polynomial identities to multiply. So to multiply this out, remember we have one negative, one positive. So it's just basically when we have a minus b into a plus b, it just becomes a squared minus b squared. So your a in this case is 25, right? And your b is minus 3x squared. So what does it become? Solving this equation, we can get, applying this formula, 25 squared minus 3x squared squared, because that's your a, that's your b. So 25 squared is 625 minus 3 squared is 9, x squared squared is multiplying the powers out, x to the power 4, and that's my answer. Looking at the next question, which is question number 23. What is the equation of a quadratic function? What is the equation of a quadratic function p with rational coefficients that has a 0 of 3 minus 5i? Since one of the 0 is already a complex number, we can write x is equal to 3 minus 5i. Automatically the other 0 becomes 3 plus 5i by the conjugate Surds theorem, the complex conjugate. So x minus 3. We can write this as bringing the 3 over, x minus 3 over. So what's a factor? Bringing the 3 over and bringing the 5 over, you get 5i. And this one is bringing the 3 over and bringing the 5 over, you get minus 5i, and make it equal to 0 because we want to find the quadratic equation. Since we want to find the equation, that's the reason why we say it is equal to 0. If we want a function, then we just don't say equal to 0. This is the quadratic. Now we can identify this as a plus b into a minus b. So identifying this as a plus b into a minus b, this is your a and this is your b. 5i, your a is x minus 3 and your 5i is your b. So we kind of have like difference of two squares as well. So this is just a minus this is x minus 3 squared minus 5i squared, which is equal to 0. X minus 3 squared is x squared. Remember the middle term is plus 2ab, so minus 6x, because x times minus 3 is minus 3x, and doubling that or times 2 will give us minus 6x. Minus 3 squared is 9, and 5i squared is minus 25i squared. But remember, I squared is equal to negative 1. Because why? I is equal to square root of minus 1. Squaring both sides will give us I squared is equal to negative 1. Now, remember the value of I squared is negative 1. So negative 1 times 25 will be plus 25. So you got x squared minus 6x plus 9 plus 25 is equal to 0. We will put this in the equation solver on the calculator and show you that you will get these two roots. Remember, this second root is automatically from the theorem, okay? From the complex conjugate theorem. So x squared minus 6x and 25 plus 9 is 34 is equal to 0. Now let's check on the equation solver if we get the same answer. So we'll go to mode, we'll go to equation which is 5, and we'll go to 3, and we'll enter 1 equals minus 6 equals and 24, right? Not 24, sorry, 34 equals. Now 3 plus 5i, remember that's one of the root, the second root, and the first root was given was 3 minus 5i, so we do get the answers. Perfect. So we can go back to the right, looking at question number 23. What is the equation of a polynomial function p with rational coefficients that has a 0 of 2 minus root 3 and negative 5i? So same concept as the previous question. So the 0 is, now what we want, what is the equation? We still want the equation. So x is equal to 2 minus root 3, so automatically the second root will become plus root 3, conjugate Surds theorem. X is equal to 2 plus square root of 3. The second root that was given was in complex numbers. It was x is equal to minus 5i, so automatically the second root will be x is equal to positive 5i. Remember, the first root and the third root was given. We just use the conjugates to get the others. Remember, we got this one and we got this one. The sign is positive in the front. If it's negative, then it's positive. If it's positive, then the other root will be negative in front of the surd only and in front of the complex number only. Now writing this in equation form, we bring everything over. Since is x to the power 4 function, what is the equation of a polynomial function that has these zeros? These are the only zeros. If these are the zeros, then by the conjugate Surds theorem there are 4 roots. 4 roots means x to the power 4 function. That's what we are trying to find. So we will bring everything over. We need 4 brackets. So x minus 2, bring that over, positive root 3. X minus 2, bring that over, negative root 3, and bring this over, you get x plus 5i, and bring that over, you get x minus 5i is equal to 0. Now again, the first part is difference of two squares, because we can group this up as a, and you got one positive, one negative, and you can group the second one up as B. And same story here in the second in the last two brackets. You also have difference of two squares there. So now this first bracket will just become x minus 2 squared minus root 3 squared. Make sure you put that in bracket as well, because everything is being multiplied by each other. And then the next one is x squared minus 5i in bracket squared there. So put that in bracket as well, is equal to 0. Now this is x squared minus 4x plus 4, and this is square root of root 3 squared is minus 3, and this one is x squared minus 25i squared. Now remember, I squared is negative 1, so it will become plus 25. So what do we have here? We have x squared minus 4x plus 4 minus 3 is plus 1, and this is x squared plus 25, because I squared is minus 1 is equal to 0. Now opening the brackets up and solving the equation, x squared times x squared is x to the power 4. X squared times 25 is plus 25x squared. Minus 4x times x squared is minus 4x cubed. Minus 4x times 25 is minus 100x. Then 1 times x squared is x squared, and 1 times 25 is plus 25, which is equal to 0. Now we solve. Now simplifying this equation, we got x to the power 4. Remember, we have like terms, so like terms are x squared and x squared. Those are the only like terms. So solving this, we'll get x to the power 4. Then the next one is minus 4x cubed x to the power 4 minus 4x cubed plus 26x squared minus 100x plus 25. So that's the answer we're looking for. So let's write it out. X to the power 4 minus 4x cubed plus 26x squared minus 100x plus 25 is equal to 0. And you know, x to the power 4 function must have like 5 terms. That's here. Next one, use polynomial identities to factor and solve for all the roots. Because we need to solve for all the roots is something similar to what we have done before as well. This is the sum and difference of two cubes. This is the sum of two cubes. So the cube root of 27 is 3. The cube root of x cubed is x. The cube root of 216 is 6. So we got this. Second bracket will be, the second bracket will be by the way guys, this one here, because we got 27x cubed plus 216, we're getting 3x plus 6 in the first bracket, which means we can still divide this we can divide this entire equation by 9, I think. Yeah, let's see, 27, we can still simplify this equation. So let's see, 27 divided by 9, we get 3, and 216 divided by 9, we get 24. 3 and 24. So I think we can divide the entire equation by 27. So 216 divided by 27, is that possible? Yes. So we can actually simplify this equation by dividing it by 27, because when you're solving an equation it must be in standard form. This is not really in standard form, so it's x cubed plus 8 is equal to 0. So this is more easier to solve than the previous one. And how I knew that? Because my first bracket ended up with factors. So x cubed plus 8 is equal to 0. That's what we are solving. So this is sum of 2 cubes. So x plus 2 into x squared, product of these two with the opposite sign, minus 2x plus 4. We square the 2 is equal to 0. Remember, a cubed plus b cubed is equal to a plus b into a squared minus ab plus b squared. So your a in this case is x and your b in this case is 2, because cube root of 8 is 2. So that's what we have. So from the first equation we can get x is equal to negative 2, and from the second bracket we need to use a quadratic formula, which is minus b plus minus the square root of b squared minus 4ac divided by 2a. Minus b will be, your b value is minus 2, so 2 plus minus b squared will be minus 2 all squared, which is 4, and 4ac, 4 times 1 is 4, minus so minus 4 times 4 is minus 16, so you'll get minus 16 there, divided by 2a divided by 2. 2 divided by 2 is 1, plus minus, if I find the square root of negative 12, or remember the square root of negative 12 is I, and the square root of 12 will be root 12 will give me 2 root 3. So 2 root 3. Yes, it will be 2 root 3 over 2. Now remember, this part is still being divided by 2, so it's going to be 1 plus minus root 3i. And now we can also check these answers. We have solved for all the roots. One is a real root and the other two are complex. So 2 complex roots plus 1 real root gives me 3 roots, and it's x to the power 3, so you must have 3 roots, not necessarily real roots. You can have real plus complex roots. That's why you got x to the power 3 giving you 3 roots. Let's solve the inequality. Because we have minus x cubed minus 9x squared plus 10x is greater than 0. Remember, this inequality is a cubic inequality. In other words, we need to write this in standard form. So we're going to multiply everything by negative. So negative x cubed becomes positive x cubed plus 9x squared minus 10x is less than 0. Because when you multiply and divide by a negative, we change the inequality. Divide by negative or multiply by negative, same thing, by negative. So what happened here was that the inequality sign changed. You can see the inequality, the sign changed because you divided by a negative or you multiply by negative. Now rule number 1 of factorization is to take out the highest common factor. The highest common factor is x. X is common to everything, so x into x squared plus 9x minus 10 is less than 0. And as we can see here, we have a quadratic function, so we can factorize this. So x and x, I think you get 10 and you get positive 10 and negative 1. You can use the quadratic function factorization on the calculator and get this. So if I try to use that on the calculator, look, so you get 5, 3, and you press 1, 9 and negative 10, and what do we get? X is equal to 1, so you flip the sign, you bring this over, opposite sign, and it was negative 10, so it becomes positive 10. Now solving this inequality, so we always start with a line graph and put all the zeros. Let's put all the zeros on this line graph. So what are the zeros? The zeros are negative 10, 0 and 1. Take any value after 1, like 100. If I take 100, positive, 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 I'm getting a positive, then negative here, positive here, and negative there. You can alternate the sign after you get any one of them, because you have different spaces to alternate the sign in. And we are looking for a negative answer, so the answer is between 0 and 1, or x is less than negative 10. So x is less than negative 10 or 0 to 1. So we can write this answer as x is an element from negative infinity to negative 10 union 0 to 1. And finally, this brings us to the last question. Use the rational roots theorem to find all the roots of the equation. So how are we going to find all the roots of the equation? We have done it before as well. So we list all the possible factors. So p is the last value. So factors of 18. So we're going to say is 1. 1 can divide 18. 2 can divide 18. 3 can divide 18. 6 can divide 18. 12 can't divide 18. After 6 is 9. 9 can also divide 18. And then 18 can divide 18. These are all the possible factors of 18 and all the possible factors of 4, which is the leading coefficient. Remember, the leading coefficient is 4. We are only looking at the leading coefficient, which is the number next to the highest power in the polynomial function, and the constant. P is the constant and Q is the leading coefficient. And we can list all the factors of 4. 1 can divide 4, 2 can divide 4, and 4 can divide 4. Right. So what are all the possible roots? Possible, by the rational roots theorem, possible roots are, it's written in the form P over Q, which is equal to plus minus 1. There's so many. Plus minus 1, plus minus half, 1 over 2, plus minus quarter. Right, that's done with the 1. I'm done with the 1. Let's move on to 2. Plus minus 2 over 1. So plus minus 2. Plus minus 2 over 2, no need to write because it's already there. Plus minus 2 over 4, no need to write because it's already half. So I'm done with the 2. Let's move on to 3. So plus minus 3. Plus minus 3 over 2. And plus minus 3/4. Right, so I'm done with the 3. Let's move on to 6. So plus minus 6. Plus minus 6 over 2, which is 3, no need to write. Plus minus 6 over 4, which is 3 over 2, no need to write. So I'm done with the 6. Let's move on to 9. So you're getting plus minus 9. Plus minus 9 over 2. Plus minus 9 over 4. Yes, sir, we're done with the 9. Let's move on to 18. Plus minus 18. And then plus minus 18. Plus minus 18 over 2, which is 9. No need to write. Plus minus 18 over 4, which is 9 over 2. No need to write that as well. Now we can close. So these are all the possible factors that we can get. These are all the possible factors of the equation that we have. One second. So we can close the factors. Now you don't really need to list all the factors. If you can find something that works, that's perfect. Example, let's try 1 and see if 1 works. If I substitute 1 here, 4 minus 4, that's 0. Minus 17, 9 and 18 is 27. No, 1 does not work. Let's try minus 1. Maybe minus 1 might work. Mode 1. So 4, I'm substituting here. Negative 1 cubed is negative 1 times minus 4, which is plus 4. Minus 1 squared is 1, so minus 17. Minus 9 and plus 18. So 1 works, perfect. So since 1 works, we can say x is equal to negative 1 is a root. Since you got x is equal to negative 1 is a root, because I substituted negative 1 inside here and it worked, Let's try to find another root. So if we find another root, then we can reduce this into a quadratic. Since x is equal to -1 is a root, let's find another root. Yes, if we have two roots, then x to the power 4 function will now become x to the power 2 function. But now how will we find another root? Okay, let's try to use synthetic division, because then we can reduce this function into a cubic. And will that work? But we still have a 4 in the front. Okay, let's continue working with this. Plus minus 1 is out. Because we got x and -1, let's try maybe plus minus quarter. Let's try plus minus quarter. 1 plus minus quarter. Will quarter work? Okay, let's use synthetic division and get it into a cubic function first. Maybe the cubic function might help. So if I use synthetic division, -1 here, and put the power 4 function, at least I know I've got a cubic polynomial. I've reduced it there. Power 4 function, then I can just use a calculator and see what other roots that I can get from the cubic, because I have a cubic function calculator. So 4, we have -4, 4 minus 4 -17, 9, and we got 18. So we bring down the 4, right? After we bring down the 4, we multiply and we add. That's all we need to do. Multiplication and addition. So we multiply these two and we add them up here, right? So multiplying these two, you get -4, add them up, you get -8. -1 times -8 is 8, add them up, you get 9, and -1 times 9 is -9, you add them up, you get 0. Something's wrong. -4 minus 4 is -8. -8 times -1 is 8. -17 plus 8 is -9, and 9 plus 9 is 18. 9 plus 9 is 18, and -1 times 18 is -18, so I've got a 0. Perfect. And remember that value of 0 represents the remainder. This value of 0 represents that's a remainder, and that's my cubic function. So remember, I've already got one root. All I'm solving for now is 4x cubed. I'm solving for the other root. Just 1 second. Right, so this is a cubic function. 4x cubed minus 8x minus 9, 8x squared minus 9 plus 18 is equal to 0. Now let's see if I can find any other roots from the calculator. Obviously I'm allowed to use a calculator, so I will use it. Go to 5 and press 4. So I've got 4 minus 8 minus 9x. That should be an x there. Let's correct it. Minus 9x, and we have 18 at the end. That will give us -3/2. Perfect. So it's giving us x is equal to -3/2. It was one of the possible roots. Or x is equal to 2, or x is equal to 3/2. So we have all the 4 possible roots. Now remember, if you manage to find x equals -1, and if you manage to find x is equal to 2, you would have had a quadratic here to solve. So because we are allowed to use a calculator, we can find all the possible roots, right? So yes, so our solutions are, you can write the solution in the set. Roots are -1, 2, -3/2, and 3/2. That's in the solution. I hope you understand, guys. Don't forget to comment on the videos. If you don't understand any questions, write it in the comments, and I should be able to help you. All the best for exams, guys. Thank you.